Welcome to The Explainer. Today we're digging deep, and I mean literally, into the materials that build our world. We're talking about the stuff that's in everything from the most boring, everyday objects to the most magnificent machines. Minerals. So let's start with a simple question. This morning when you brushed your teeth, did you ever stop and think about what's actually in that toothpaste? What's given it the power to clean and shine? Well, the answer might surprise you. It's not just fluoride, it's a bunch of rocks.
No, I'm not kidding. That gritty feeling that scrubs your teeth clean, that comes from crushed silica and limestone. That brilliant white color, you can thank titanium oxide for that. The fluoride that fights cavities is derived from a mineral called fluorite. And you know that little sparkle some toothpaste have? Yep, that's mica. Heck, even the plastic tube it comes in is made from petroleum. Every single part of it was dug out of the ground.
And that little toothpaste example, well, it pulls back the curtain on a much bigger truth. Minerals are the invisible ingredients in just about everything we use, from a tiny little pin to a massive, towering skyscraper.
So what is a mineral anyway? Well, geologists have a very specific definition. It's a homogeneous, naturally occurring substance. All that really means is that it's the same all the way through, and crucially, we don't make it in a lab. It's one of nature's own building blocks for our planet. And get this, their importance goes right down to our own bodies. Minerals make up just a tiny fraction of what we eat, only about 0.3%. But here's the kicker. Without that tiny amount, our bodies literally couldn't use the other 99.7% of our food. They are absolutely essential for life.
You know, this quote, a simple explanation from a father to his son, just captures the whole thing perfectly. Our entire civilization, the buses, the trains, the factories that build them, it's all manufactured from minerals, and it all runs on energy that we also get from the earth.
Okay, so if this stuff is so important, where does it all come from? I mean, these minerals aren't just lying around on the sidewalk, right? Well, they're usually found in what we call ores, which is basically just a mix of a valuable mineral with a bunch of other less useful elements.
And geologists have figured out they show up in about 5 main ways. You can find them in veins and lodes. Those are basically cracks in rocks filled with goodies, like copper and zinc. Or they form in big horizontal layers, like coal. Sometimes they're just what's left over after surface rocks break down over time, which is how we get bauxite. You can also find them in the sands of valley floors, think gold and silver. And finally, the oceans themselves are just a massive soup of dissolved minerals like salt and manganese.
All right, so we've dug them out of the ground. Now what? How do these rocks become the very backbone of our modern world? Well, they become the raw materials that fuel our most critical industries.
Now, in the world of industry, we basically split metallic minerals into 2 big camps. You've got your ferrous minerals, that's just a fancy way of saying they have iron in them, like iron ore. Then you have the non-ferrous ones, which is everything else. Copper, bauxite, gold, you name it. And those are absolutely vital for things like electrical wiring and airplanes.
But let's be clear, the ferrous minerals, especially iron ore, are the undisputed kings. They are the absolute foundation of industrial development. In fact, they account for about 3/4 of the total value of all metallic mineral production. It truly is the backbone of industry.
Now, what's really fascinating is how concentrated these resources are. Let's take manganese. You need it to make steel. In India, just 2 states, Madhya Pradesh and Maharashtra, produce 60% of the entire country's supply. Talk about a geological lottery. But wait, it gets even more extreme. Check out bauxite, the ore that gives us aluminum. One single state, Odisha, is responsible for a mind-boggling 65% of the country's total production. That has huge economic and strategic implications. And speaking of aluminum, you have to hear this story. It's a perfect example of how our relationship with these materials can change. Back when it was first discovered, aluminum was more valuable than gold. Emperor Napoleon III used to show off to his most important guests by serving them with aluminum forks and spoons. 30 years later, new technology made it so cheap that beggars in Paris were using aluminum bowls. Amazing, right? Of course, all this work, turning rocks into things like spoons and airplanes, takes a colossal amount of energy. So the next logical question is, where does all that power come from?
Well, we get it from 2 main places. On one hand, you've got the conventional sources. These are the old workhorses, fossil fuels like coal and petroleum that have powered the modern world for centuries. And on the other hand, you have the non-conventional sources, Renewables, like solar and wind, which are becoming more and more vital for our future.
But, and you knew there was a but coming, this massive industrial and energy system doesn't come for free. The act of pulling these resources out of the ground has some really serious consequences for both people and the planet.
I mean, the process can be just brutal. Miners are constantly breathing in dust and toxic fumes that cause terrible lung diseases. They live with the daily threat of cave-ins, floods, and fires. And the damage doesn't stop at the mine entrance. It contaminates local water and pollutes the land for miles around. And some of these practices are truly harrowing. In parts of northeast India, there's a type of coal mining known as rat hole mining, where families dig these long, dangerously narrow tunnels by hand. It's so dangerous that it's been declared illegal, but it still happens.
So, this all leads us to the biggest, most important question of all. We are burning through these mineral and energy resources at an incredible rate, resources that took millions of years of geology to create.
Now get ready for this number, because it's a shocker. All of the mineral deposits that we can actually get to and mine make up just 1% of the Earth's crust. 1%. For all practical purposes, these resources are finite, and they are not renewable.
So yeah, the alarm bells are ringing. Continuing with business as usual just isn't an option. We absolutely have to find a more sustainable way to live on this planet.
And the good news is we have a roadmap. It's not easy, but it's there. It means we need better technology to use lower quality ores. It means we have to get serious about recycling metals, using scrap, and finding substitutes for the minerals that are getting harder and harder to find. These aren't just nice ideas, they're absolutely essential.
And when it comes to our energy future, it all boils down to one simple, incredibly powerful idea. Every bit of energy we save through being more efficient is energy we don't have to rip out of our finite planet. At the end of the day, energy saved is energy produced.
So from the mica that makes your toothpaste sparkle to the copper in the grid that lights your home, our modern lives are built on these finite resources. The Earth spent millions of years making them, and we're using them up in just a few centuries. The real defining challenge for all of us right now is to figure out how to build a future that respects and can live within those profound limits.